Okay, this is your video for 10-6. So we're moving into volume now as opposed to surface area. So all of our units will be cubed. The volume of a 3D figure is determined by the number of non-overlapping unit cubes of a given size that will fill the interior. So surface area is how much would it take to paint it, how much would it take to cover it up, whereas volume is how much would it take to fill the interior. With surface area, we had a problem, the difference between an oblique prism and a right prism that changed the surface area. But with volume, it does not change. So we can actually find the volume of oblique or right. So we're going to start with prisms. So the volume of any prism, let me zoom in here for you. Of any prism, the formula is BH, where B, remember, is the area of the base, and then height is the height of the figure. Now, we had some confusion over the last couple of days. Remember, height represents the distance between the two bases. So this is a triangular prism, so the triangles are the bases and the height is the distance between the two bases. How far apart are they? So it gets confusing between the height of the triangle when you're finding the area and the height of the figure, so you need to be very careful with that in your formulas. Now, a couple of shortcut formulas for a rectangular prism. Instead of doing BH, you can do length times width times height. It's hard sometimes to determine who's the base of a rectangular prism because anybody could be the base because they're all rectangles. And then another shortcut for cubes would be the volume equals S cubed, so the side length cubed there. Okay, so let's get started. Let me zoom back out. Don't cheat. Okay, so find the volume of the prism round to the nearest tenth. So this is a rectangular prism, so this is very easy. We can use our shortcut here. Volume equals length times width times height. And we're multiplying them all together in the end, so it really doesn't matter whose length, whose width, and whose height, because they're all going to get multiplied. Let me open my iPad for my calculator here. So 13 times 5 times 3. And that gives us a volume of 195 cubic centimeters. So make sure you're putting your units. Okay, try the next one by yourself. The volume of a cube, again, I would encourage you to use your shortcut of S cubed. So 15 cubed is 3375. Go ahead and try C by yourself too, the hexagonal prism. Okay, so volume equals BH. So B, we're going to replace area of the base with 1/2 AP. So I have 1/2. The apothem of a hexagon is half on the square root of 3, so 9 halves, or you could do 4.5 on the square root of 3, times the perimeter. Now I'm about to, you could put in 54 here if you wanted to. I just put in 9 times 6, and that would calculate my perimeter. And then the height of the prism is 12 here. So remember, when you put this in your calculator, you're going to put everything in except for the square root of 3. Then the square root of 3 just stays there. Okay, word problem. We've also had some confusion over the last couple of days. A word problem is a problem that uses real life. Sally did this. We have this aquarium or swimming pool or whatever. Not a math problem that uses words. This prism does this and this and this. It has to be a story. It has to be a real life concept to be considered a word problem. Here we go. A swimming pool is a rectangular prism. Estimate the volume of water in the pool in gallons when it is completely full. The density of water is about 8.33 pounds per gallon. Estimate the weight of the water in pounds. So two-step question here, but the very first part would be to start out with the volume. So length times width times height. Let's calculate that. 25 times 15 times 9. And the volume here, I'm going to try to make room, is 3375 feet cubed. Okay, but it doesn't want me to do it in feet. It wants me to do it in gallons. So let's see. If 1 gallon is equal to 0.134 feet cubed, then I need to divide by 0.134 feet cubed to get those units to cancel out. So that would be, ooh, that's a lot, 25,186.6 gallons of water. That takes a lot of water to fill up a swimming pool. Okay, moving on to the next part. The density of water is 8.33 pounds per gallon. Estimate the weight of water in pounds. So if you have a hard time with conversions, think about it like this. 8.33 pounds per 1 gallon. I'm trying to get gallons to cancel out. So if gallons is on the bottom here, then I need this gallon to be on the top, so that when I multiply, I don't know why I keep putting two L's, gallons and gallons, that will cancel out. Gallons will cancel out with gallons, and it will leave me with pounds. So this is actually a multiply problem, whereas over here I wanted feet cubed and feet cubed to cancel out, so that was a divide problem. So that's one way to look at it. So here we go, 8.33 times our previous answer. I'm trying to use my new calculator here. And I got 209,804 pounds. Woo. Water's heavy. Okay, so 209,804 pounds of water to fill up that pool. That's kind of a big number. Alright, moving on to cylinders. Volume of a cylinder for any prism, even a cylinder, the formula is still BH. The beauty of a cylinder is that I know what the base is. I know the base has to be a circle. So I can go ahead and substitute in that pi r squared in for area of the base, because it's always going to be a circle if it's a cylinder. Okay, so let's zoom out and go back to work here. So here you see an oblique cylinder, which is going to be the same thing. We just have to make sure we get that perpendicular height, not a slant height, because that's not the same thing. So let's start with our formula. I'm going to keep encouraging y'all to do this. Over the last couple of days, we've made several mistakes because we didn't write down our formula. Now, they gave me the diameter, not the radius, so make sure you cut that in half. And the height is 14. So let's say 81 times 14 is 1134 pi inches cubed. Super easy. Okay, go ahead and try the next one. Okay, this one you had to do a little bit of work. It was easy up front because they gave you area of the base. So they gave you big B. But in order to find the height, we had to go ahead and find radius anyway. So we went ahead and we set that equal to pi r squared to figure out the radius was 11. And if the radius is 11, then the height must be 22. Then we can go back over here and plug that in. 2662 pi centimeters cubed. Our last example is, as always, changing of dimensions. So if the radius and height of a cylinder, now remember that's the only dimensions for a cylinder because it's pi r squared h. So r is getting used twice and the height is getting used once. So that's our 3 dimensions. So when they say they're changing the radius and the height, that means they're changing everybody. So if your scale factor is 2/3, that's 3 things for volume. Radius, radius again, and then height. So I'm going to cube my scale factor. So I'm going to say the volume is multiplied by 8/27. Okay, try the last one by yourself. Length, width, and height. So we have all 3 of them are doubled. Doubled means scale factor is 2. 2 cubed is 8, so it's multiplied by 8. Now, that was a pretty easy one as far as the examples go, so we'll step up the examples when we get to class tomorrow. See ya.